So I would like to welcome you to the next lecture of Voyages in Language Technology. And we would like to acknowledge the First Nations people as the original inhabitants and the traditional owners of the land on which this course was developed and is being delivered. This land is Meanjin, also known as Brisbane. We pay deep respects to all elders, past, present, and emerging on this land and the lands from which we are presenting and attending. So it gives me great pleasure today to welcome Professor Daniel Angus, who is a Professor of Digital Communications at QUT's Digital Media Research Centre. Dan has a long history of working with our group in language technologies, and I'll leave it to him to introduce the chatbots and the work he's going to present today. Over to you, Dan.
Thank you so much, Janet. And yes, I've had a beautiful history with you and the lab over there, and continue to do so. And I really love this course. I mean, it's such an awesome course and so necessary in this present moment to understand language technologies and kind of the ways in which they're entering and impacting on society. So I have some slides. I am going to share my screen and give an outline of what it is we're going to talk about today. So yes, there we go. Hopefully that should be coming through okay. So I titled this talk, Hey Siri, how should I title my talk? And sorry, I'll try and refrain from using trigger words while I'm talking about chat technologies, so I don't set off every phone on the chat or while people are watching the video later on. But this is very much like the focus of today, is talking about largely consumer chat technologies, some of the ways in which they're being used, developed, and also a bit of a history lesson as to how did we get to this point in time. And I think it's important to understand that no technology exists in isolation. Technologies are developed, throughout time, and they carry the baggage of that kind of legacy technology or research from whence they've kind of been developed. So that's where a lot of today's focus is on, is kind of looking back so that we can understand the breadcrumbs that have been left to kind of reach us to this particular point. And then I guess moving forward is then how do we understand that to then maybe uncouple ourselves a little bit from that legacy maybe and completely rethink and reinvent what this technology can do. How do we understand its impact, I guess, in shaping our own imaginaries around what this technology can do. So to kick us off, I just want to give a bit of an overview of when I say bot, what do I mean? We do a lot of bot studies here in our DMRC. So I'm a program leader here in the DMRC. I lead a program called Computational Communication and Culture. Within that, we have a wonderful array of amazing researchers. So one of my good colleagues, Dr. Tim Graham, he just recently got a DECRA fellowship to look at inauthentic behavior, coordinated inauthentic behavior on social media. Now, that's often just referred to as bots. So things on, say, Twitter, where you have an account, a username who is fully automated or perhaps acting in a way that we might look at and think that doesn't look authentic, it doesn't look human, it's somehow semi-automated or fully automated. And that's what people understand to be bots in, say, that space. A wider definition might be pretty much any computer program. It's interesting being in a space like communication, where pretty much anything that I look at and go, that's just a pretty standard deterministic algorithm, people might consider and call it a bot. So there was a movement about a decade ago where pretty much any computer program that interfaced with social systems like social media was considered to be a bot. But really, it's about an entity in some way that is acting according to some set of rules. In many definitions, the idea it's acting autonomously, right? So there's not necessarily something pulling strings behind it, that it's able to act on its own accord. So that might be, necessarily needing a trigger, so some kind of a question or some kind of a button push to get it working. But otherwise, it is then at that point acting in some kind of autonomous fashion. And what we see in the definitions from the comms literature is that there are often specializations depending on the domain or their function. So we see things like web bots. So these might be scrapers that go around that collect data from the open web via hyperlink networks. It could be things like chatbots that we design to specifically chat and interact. Twitter bots, I gave an example of with Tim's research, bots developed for Twitter as a specific platform to go there and to do certain things, or other kinds of social bots that might inhabit various platforms. So platforms like Reddit is a great example of where there are lots of different bots. There's one incredibly funny example of this, of a bot that just posts singular emojis of mushrooms. And this bot has caused havoc on that platform because it just appears, and then just these emojis start appearing like mushrooms kind of sprouting in every kind of back subreddit. And it's led to really interesting reactions from the community. Some to see it as funny, others see it as incredibly disruptive. So yeah, really interesting ways in which particular bots can inhabit very specific platforms and then function within those, cause disruption, maybe some amusement, but yeah, create tension nonetheless. Game bots as well, another great case where developing, AIs or other bots to play games. So either, very kind of sophisticated, say, first-person shooter games, or just, simple AIs that, or indeed, very advanced AIs that play games like Go, chess, or others. And then cash bots, right? So specific bots that are out, as the name suggests, to try to make money. So either through scams or through other kinds of automation, try and gain some kind of financial advantage from the system they inhabit. So yeah, a bit of an example of where some of this research sits here at QT. So if you cast your mind back to 2019, 2020, where we had incredibly concerning bushfires across most of Australia, what we saw was some very concerning activity on Twitter around hashtags like this particular hashtag #ArsenEmergency. So this was a campaign that we believe was set up to try to distract from the dominant conversation on social media that was relating to climate change, right? To pin the dominant cause and particularly with the intensity and the severity of the bushfires was, unequivocally, linked to climate change and human-induced activities that have created that situation. But this hashtag campaign on Twitter tried to distract from that, tried to set an agenda and a frame away from this discussion of climate change. And we picked this up early and found that through analysis of the accounts that were promoting this particular hashtag and were saying, yeah, it's all about us, and yeah, that's where we need to look, were very suspicious, right? The kinds of posting behaviors, the frequency of their posting, what times of day, the kinds of messaging suggested that they were not authentic actors. This is not you or I who are on the platform. If you follow me on Twitter, I will be posting links to academic kind of articles and discussion around topics like we're talking about today. I'll also be, perhaps posting rants about the lack of cycling infrastructure in Brisbane or something like that. But there is an authenticity to that discourse. If you follow it for long enough, you can kind of get a picture of kind of the person I am. These accounts are not that. They are the complete opposite. They might be highly fixated on a very, very specific line of kind of questioning or discourse. They can often appear to repeat the same messages again and again and again. And there's various other triggers that we look for. But yeah, studying this, we found a number of Twitter accounts that were engaging in this kind of inauthentic discourse. And it's incredibly concerning because when this starts to impact on debates, political debates on platforms, that's a problem, right? We consider, and other colleagues here in DMRC, like Professor Axel Bruns, who's just won a laureate fellowship to study this exact issue. We're interested in looking at things like political polarization online. These kinds of accounts disrupt our public discussion and discourse. So social media is a great space and can be a great space for us to discuss issues of a political nature or a broader societal nature. Having these kinds of disruptions on there can distract and move that debate in ways that are just not really not really authentic and not really helpful. So that's why we look at this and study it. So let's go back to bots in general. And I said I'd give a history lesson. So let's start there. And I should say as well, at any point, please throw questions in chat or just chime in with comments if you like. But there'll be plenty of time for some interaction. I've got some little workshopy examples as we go through. So hopefully it's not just going to be me talking. But the Turing test. So this might not be something that is necessarily new for most people, but back in 1950, Alan Turing wrote a paper that was published in Mind, the journal Mind, called Computing Machinery and Intelligence. And in that, he put out a thought experiment around this idea of what we now commonly refer to as the Turing test. He called it the imitation game. And really the imitation game was this kind of situation as you see here on the slide, where you have an agent, a person, as person C, who is communicating through a closed wall with this conversational partner A and this conversational partner B. And the real, just distilling it down from this particular paper and the specifics, the question is, can C at some point know whether they are communicating with a human or a computer? Now that's really interesting as a thought experiment about what are the limits and how do we even define and understand intelligence. It led to some of what I think are the greatest debates in computer science. The emergence of then follow-up studies, the Chinese room puzzle was another thing that came from this, where they kind of added another layer of translation in the middle, and numerous kind of iterations of this idea. But yeah, the basic premise being that if you can fool human C into believing that, say, A is a human in this case, you might have created an intelligent machine. And so, yeah, as I said, lots of discussion ensued for now, decades since this has been published around what even is intelligence. And the entire connectionist movement debated this at length. And so I won't rehash those arguments here. And so, in fact, we just don't have time. But yeah, a really interesting moment in time to begin what I think is some of the greatest debate that we've ever had as a field. It also kind of later on birthed this particular prize called the Leibniz Prize, which is a prize awarded to a chatbot every year. They have a competition where people design chatbots, and the intent being very much in line with Turing's imitation game is creating the machine that can trick the judging panel the best. Right, so who can create the most human-like chatbot and have it work within a particular set of conditions in a particular environment? And there's a really interesting list of chatbots, some of which I'm going to talk about now, that have been awarded that prize. And yeah, they, as the years go on, they increase in their sophistication. And indeed, we would consider, according to this 1950 paper, that well and truly we've created machines that can fool a human into believing they're talking with another human when in fact they're talking with a computer. That kind of threshold has been passed. But yeah, what that means in terms of is that true intelligence or not, I leave that one open. So the first chatbot that was developed by Joseph Weizenbaum in 1966. Now, Weizenbaum, when he developed this particular chatbot, didn't do it necessarily in some kind of serious fashion. This was not, hey, I really want to develop a chatbot and make it as sophisticated as possible and have it there as a serious piece of technology. No, this was a whimsical experiment. It was he designed it in many ways, as he reflected in later years, to show why you wouldn't do this. It was in fact like an anti-technology where he designed it to show what a terrible idea it would be to create a chatbot. But it kind of had the opposite effect. And Eliza then birthed a number of kind of clones and developments from it where people tried to improve upon the basics of this chat engine. So yeah, really interesting. And some of Weizenbaum's later reflections on this are incredibly interesting. So, as I said, I'm going to try and not talk at you too much today, but I've got a few activities dotted through. So if you want to, and I'll try and copy this into the chat, this particular link. But yeah, if you want to have a crack at chatting with Eliza, now's the time that you can do that. So we'll take, just a few minutes, have a look at this link at massverc.at/Eliza bot. And yeah, as I said, I'll jump out and chuck it in the chat. Or in fact, Ben's done it already. Thanks so much, Ben. So yeah, you can have a go at that and have a go at chatting with Eliza. And so yeah, I'll stop my share and just take a few seconds or a few minutes to have a brief chat with Eliza. And as you're doing so, it would be great if you want to chuck any chat threads into our chat. So, anything that you are happy to share in your chat with your Eliza, please throw it into the chat here.
Looks like we've got the same bot then.
I think we've got the same one.
That's
We're all
right.
going to have a similar Eliza experience, because Eliza is a pretty limited chatbot. Has a very simple set of rules and chat dialogue, and it was developed to represent a mock Rogerian psychotherapist, right? So its dialogue is kind of interesting in how it asks a lot of questions and it reframes your responses back towards you all the time. So like in this example, please tell me what's been bothering you, right? So a classic kind of psychotherapist opener. And I say, I'm giving a lecture right now. Do you know anyone else who's giving a lecture right now? It's that constant kind of Socratic style of discourse of never really giving a full and concrete answer, and continues to question. And yeah, even the fact that it's saying, you're being negative, right? Is I would like to think that we've developed our understanding of psychology practices since that point, that this has been developed as well. All right, I'm going to go back to my slides and reshare. So yeah, really interesting that as the first kind of chatbot, and we can come back to discuss that in a little bit about its influence over how we develop chatbots even today. So what was really interesting then is how this developed. As I said, this was developed more as a whimsy than a serious technology at that point in time. And in a few years later, Kenneth Colby developed it's like the kind of flip side, right? So if Eliza was the psychotherapist, then Parry was the patient, was a paranoid schizophrenic. And I think the intent here was always to put them, kind of engage them with each other and see what would happen. And that indeed happened at this particular conference, the Network Working Group. And you see at the top here, so this is Vince Cerf that did this, who's one of the kind of founding members of like inventors of the internet. So at this particular conference in '73, they put Eliza into conversation with Parry, and this is a bit of an excerpt from the transcript of what happened. Which, look, if I was reading this as a particular transcript that I was analyzing, it seems plausible to a degree, right? This is not too artificial and not too disjoint. It's yeah, a really interesting moment. So beyond that, then something happened. So as I said, up to this point, these have been more of a whimsy, and these things were put up not in a serious fashion. So when that was kind of done at this particular conference in the 70s, it wasn't done in a serious kind of academic context. This was, hey, let's do this for fun, and let's have a bit of fun with this. But through the 80s, we saw chatbots start to be developed in a more serious way, right? That people, I think, started to think, no, there's something here that like we should develop this technology in a way to try to advance it and make it better. And so the first incarnation of Jabberwocky was 81, but it was released fully online in the late 90s. And it was one of the first chatbots that could reuse previous conversational data. So the idea that it would have a memory now, that chat encounters, so Eliza and Parry and others, you loaded them, you chatted with them, and then once you logged off and ended the session, everything disappeared. Jabberwocky had a memory and would take on previous conversations and use that as a database of chat scripts. And so this is very much the precursor to a much more modern chatbot called Cleverbot. And indeed, lots of other chatbots that are now using and relying on data from other encounters as part of their chat engine in some way. And we'll talk about the dangers of doing that as well, with particular cases like Microsoft Tay, and how we need to be careful about using previous encounters. The next big development was around a chatbot called Alice, which was developed by Richard Wallace in '95. And one of the biggest things with Alice is not Alice just as a chatbot, but it was the engine that underpinned it, which was called Artificial Linguistic Internet Computer Entity. Alice was its thing. AIML, which is Artificial Intelligence Markup Language, was the engine that underpinned this. What AIML is like any markup language, like HTML or XML or JSON or any of these. It is a template of how you might construct knowledge, right? And then have it re-represented. So in this case, while HTML is a spec to help us write web pages and have them render in a web browser, AIML is a markup language for consistency in how we design and template chat. And so we've had to play around with AIML in previous projects in the lab there at UQ around things like technology specific for dementia communities or those in the elderly communities around developing specific knowledges in this kind of a chat format and embedding that in a particular chat technology. We called ours Harley, and it used AIML at its heart. But I will say this, like AIML is a well-specified language. It does make coding chat technologies easy because it has consistency. It is able to be integrated in a number of different common software frameworks. And there is also you can write it in a very deterministic way. And you can also write some stochastic behavior in there. So there is a possibility with AIML to have multiple responses and have an engine that throws a coin and doesn't always give the same response, right? So it can pick from, say, a template of multiple different responses in response to a question. Where AML, like this kind of approach can be really good, though, is in fields like journalism. So journalism is playing around a lot with chat technologies right now. I've got some good colleagues at ABC that are building chat tech into smart speakers that we might have at home for things like disaster reporting. So if you have a chat tech, like a smart speaker at home, and you're tuned into an ABC app, very soon it will be able to cut in and tell you if there is a storm approaching, that there's a bushfire coming, there's floods, there's whatever might be happening in terms of a significant weather event or disaster that is happening, or some other kind of emergency alert. We'll be able to cut in and specialize that for you. So very much in line with this idea of templating, we'll be able to take information it has about your location, your name, your other details, and personalize its dialogue specifically for you, which is really interesting. But obviously, it needs accuracy. You need this to be consistent in the manner in which it communicates that information with that audience. And so that's a good thing with AIML, is that it is very granular in terms of the chat responses and very specific. It doesn't, you don't have any kind of concern around it saying the wrong thing to an audience. All right. What then happened, aside from just the chat engines themselves, is that through the kind of 1950s and then beyond, we saw that voice was a really interesting thing that many in the computer and IT space were playing around with, mostly as an interface. So, the dream and I guess the science fiction imaginary of talking to computers. Computer do this, computer do that. We see it in Star Trek, we see it in Kubrick's films, we see it in a lot of places in that imaginary around how we as humans bark orders at our computers to get them to do things. So that's where really speech to text was being driven from. HMMs, hidden Markov models, drove massive advances of this technology in the 80s, but advances plateaued into the noughties, right? We hit a point where this technology didn't really seem to be advancing significantly beyond a certain kind of level of accuracy. What then happened was we got the big data and deep learning revolution. So, Hinton and LeCun and others, made their breakthroughs with regards to deep learning. And once again, we saw an opening up of that field in terms of the advances that could be made. And so now we have very sophisticated speech to text technologies, largely driven from a data perspective, right? So having got lots of speech to text data, we can now make advances there. And I'm sure you've been doing work in this space, particularly with the work that Ben and others in the Center of Excellence are leading within doing this for languages other than English and minority languages. So where these two roads then meet, right? So we've had all that chat tech development from ELIZA all the way through. We now also have the ability to work with speech, right? So we don't just have to type our kind of interaction in, we can speak it. This led to the consumer revolution in speech bots. So our various technologies listed there, as I said, I won't mention them in case I set off every phone in the room, but this idea of devices that we carry around with us having the ability to take instruction, to engage in something more akin to a conversation with us. Now, this interaction we have with them is what we know as adjacency pairs, right? Largely action question driven dialogue. So do this thing. What is this? Tell me this, schedule this. So it's very much driven through an immediate need for information, some kind of action to be taken. And so, we know these within the conversation analysis community as the adjacency pair. So the late Harvey Sachs and Emmanuel Shchegalov talked about this in their classic paper called Opening Up Closings, where they talk about these kinds of ideas of adjacency pairs. So question response pairs that always seem to happen together. So what, just a sec. I thought I had an exercise here. It might be a little bit later around adjacency pairs. I think I might have it a little bit later. So I'll keep going. So one of the legacy problems then is how I think computer science views conversation. So take that kind of moment now where we have the collision of speech and speech to text technologies with chat technologies coming together. What we've done for the better part of 60, 70 years is take the Turing test almost as a gold standard for what makes a better chatbot. Even the existence of the Leibniz Prize and others reinforce a notion that good conversation or good chat is about fooling the human into thinking they're speaking with another human. That's set then as the gold standard. And when you set gold standards, you've got to be careful because, is that gold standard what we actually want? And is that something that is going to lead to, the most significant advances, or what kind of a technology, or, in whose view are we building and designing a technology? So most of these bots that we're building are built and tested on lexical features, right? On specific, as I said, adjacency pairs, question in, answer out. How well does it correspond with that. That's how they're judged, right? It's very dense on the information transfer, right? If we think almost like a kind of a Shannon entropy frame here of, how good is a chatbot in the case of smart bots? How good are they at doing tasks? And these speech bots have very much extended that frame of logic. There's an example of this in Google Duplex. So Google Duplex, and I'm going to click across here, and I'm just going to have to stop my share, and I'll reshare when I get it up. But Google's Duplex has very much extended this frame and this logic within their newer technologies. I imagine most of you have probably seen Duplex, but I'll share it just the same, and I'll make sure I share my audio. Yes, cool. All right, so Duplex was developed as a chat technology, a speech technology, and here it is. This is a bot scheduling a hair appointment to get a haircut for their client. So let's listen to this.
So how can I help you?
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
Mm-hmm.
Sure, what time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
So that was Google Duplex booking a hair appointment. There's a few things that stand out to me, and I'm wondering what stood out to you. And please chuck it in the chat or open up your microphones and we can have a talk about this. Is there anything that struck you within that conversation on either side of that particular conversation is interesting? Exactly, right? There's back channeling. Right, that's the classic back channeling there. I'll play it again just so we've all got that bit. Right near the start here, there's.
So how can I help you?
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
Mm-hmm.
There it is, right?
Sure.
Now, that seems very subtle, but that's something that's completely programmed. It is incredibly intentional on the part of that chat bot. And they're doing it to maintain a flow, right? And this is everything that, people like Sachs and Sheglov and Heritage and others have talked about for the longest time within the conversation analysis community, is that dynamic of the conversation, right? The back and forth that I insert ums and ahs throughout a lot of my conversation. I listen to myself do a radio interview and cringe at the amount of this I do. But it's something we do or somewhat unconsciously within our conversation, and not doing it can make a conversation feel unnatural, right? That if we're not doing back channeling or signaling whose turn it is to talk, right? So a lot of this back channeling we do is often to hold the conversation in our hand. So I'm not going to stop and let you, take over. I'm going to retain my turn in some way. This kind of thing has been studied for the longest time. But what Duplex signals in many ways here is a shift of technology in that direction, where they're starting to try and leverage those little kind of, things that make conversation work into the technology itself. And so in this case, it's really interesting also the messiness of that interaction. Now, it's a very transactional interaction, but there's still a bit of messiness there, right? The person's asking, well, what kind of haircut does your client want? Just a women's haircut, right? Now, in this particular case, they kind of got lucky on the Google side that they didn't say, but hang on, like what specific kind of cut do you want? And really drilled hard to get them to answer definitively, well, is it a cut and color? Is it, what might it be? And we're just happy to go, all right, fine, no worries. We're just going to cut some hair and that's fine. And we can do it at 10 o'clock. But yeah, it shows where this technology is kind of going. So I'm just going to chuck across back to my slides. Are there any other?
Just about that, drilling down into the type of haircut, you'd think that if they programmed that thing to have that sort of sophistication of back channeling, that they would also have some kind of knowledge about types of haircuts.
Yeah.
So is it
yeah,
likely that it would have survived more interrogation at that level as well?
Possibly. And there's another trick that it's doing, which is you find in a lot of these speech technologies, which is it's putting a lot of the work and repair work onto the human. So in a lot of cases, humans are very good at doing what we call repair work. So when the technology stumbles, the human fills in the gaps and the human kind of does the work and labor of getting the conversation back on track. Like there is an investment almost from the human side to make the conversation smoother. And so, yeah, you're quite right, Ben. Even if they drilled there, they might have just at some point gone, yeah, and then that might already be interpreted like that the fact that they said, okay, just a woman's haircut is some light form of repair work going, I'm not going to get any more detail here. I can tell I'm just going to put it in as a haircut and we'll figure it out when they come in. So yeah. And also, yeah, in the chat, absolutely right. The Hunter's points, the variance, and that's the prosodic features. We'll talk about that in a sec, that the idea, it doesn't vary, right? It seems like a almost robotic tone, very, very monotonal. It doesn't, it's not like one of the old technologies at like the railway where it's like the 7:30 train is now departing from, right? They've managed to build the technology now to smooth that. So it's more kind of human-like, but still it's incredibly monotonal. There's no real emotion necessarily or affect embedded into that conversation either. But you better believe that's something that they'll be looking at and doing in later versions of this technology. So really, I guess where I wanted to take that and why I show it is that it's an example. Now this is my contention, is that in many ways, computer science views conversation in a very transactional fashion, right? It's always about information transfer. And even just looking at the examples that Google put up of this technology is, how can we build a technology to help people book haircuts and book tables at restaurants, right? That they have to be the most uninspiring examples of conversation I've ever seen, right? They are just boring, right? But it's very much the view of like the technology as slave, right? As a subservient, serving us, the human masters, to perform mundane tasks and do this. But also it's an example in the way that they're approaching this with that monotonal observation as well, that these systems take human speech, they convert it to text, they do some kind of like, be it AI/ML or other kinds of intelligence over the top of the content, the actual the words and the concepts that are embedded there, and then create a response and convert that back into speech. Right? They're not operating at some kind of more pragmatic layer. It's very much this pipeline of how do we extract information from a statement, formulate a response, and synthesize that as speech back to the person. So this is where I want to get to with kind of a challenge almost for computer science, to say that conversation is more than just information transfer, right? Conversation's messy, it's dynamic, it's turn taking is anything but neat. We interrupt each other, we talk over the top of each other, we give long pauses, short pauses. These things are not neat in any sense. They are messy, and they're necessarily messy. This idea of trouble and repair. So how we stumble words and maybe self-repair that. So we stutter, but we then stop ourselves, pause, reframe or rephrase our question or statement. These things are the norm. You would have even heard in that duplex example, lots of this, right? If you go down to the word by word level, you will see a lot of trouble occurring there, and also repair, where people are clarifying or kind of offering those repairs of their own statements or others. Not everything is literal either. This is where tone plays a very important role, right? That the idea of me saying, I haven't been able to travel all year. That's just great. That's something you can hear in my tone. I don't mean that that's literally a great thing. That's a bad thing. So yeah, we have to be cautious around this about how we ground our meaning as well within social contexts. So statements people make are made in reflection of what we know about their personality. So we can interpret if someone's being sarcastic, or what their real meaning and a sub-meaning beyond a statement might be based on our understanding. And then also those words have specific meanings within specific communities. All these things are negotiated and culturally situated as well, right? So even that idea of turn timing and what one culture might consider to be rude behavior, another might see the complete opposite way. So in some cultures, leaving long pauses or offering declarative statements around questions, that's the norm. I remember when I was traveling and working in Europe, and I was in Switzerland, and you would pass other Europeans in the corridor, and I'd always say, "Hey, how you going?" And as an Australian, that's just a form of greeting and address, right? How you going? And these people would stop and expect, I want a conversation, like I want a full conversation with them. So yeah, those norms are culturally, situated. And yeah, I had to learn to just say hello instead of opening up with a question that they felt compelled to answer. So how do we go with this? Like, how do we move beyond this present moment where we're kind of captured, I think, in our thinking around legacy, chatbots and the Turing test in developing our chat technologies? Well, I would like to think that we can open up through ideas like mixed methods, particularly interdisciplinary work that works across linguists, conversation analysts, technologists, and others, that we look at multimodality, right? A lot of these systems are still based in text and text input and transfer, rather than looking at those other layers, tone and timing around interaction. More than anything, though, we need transferable and extensible solutions. So one of the biggest frustrations in building technology in this space has been that I was talking about that kind of revolution in deep learning and machine learning that happened, that have largely solved in some ways much of the speech to text issues that we were presented with in the latter part of the 90s and early noughties. They're not open source, right? Most of those systems that exist on our phones or in other devices are all closed proprietary systems. So if we're building other technologies that we want to use to then extend that and build the next generation of technology, it's very difficult to do that because we're locked into using proprietary black box systems that we can't interrogate and understand how they work. So what do we need to do? Well, we need to codify conversational rules and norms. So we need to do the hard work of looking into the literature that exists in discourse analysis and conversation analysis, looking at the rules and norms that have been discussed there for decades, and think, well, are there other signals here that we, coming from a computer science or IT or a mathematical perspective, can codify in some way? Can we actually build deterministic or non-deterministic rule sets around these known behaviors? Can we then build that in the public domain so we can actually extend on this and build systems that are open and inspectable? How do we share our insights, not just our data? So as we build these, we build our own internal heuristics about what works and what doesn't, but often we're just sharing data, not those insights that we build along the way. One of the biggest lessons in working with Janet's lab and with systems like the ones I've talked about, like Harley and others, that are built around specific use cases, like people living with dementia or Parkinson's or other kinds of neurodegenerative conditions, is how do we work better with those end users? How do we build these technologies with their use cases in mind, and their particular social situation in mind, and fundamentally, how do we understand the limitations of machine learning and big data? So these things can be good to shortcut solutions, but they don't necessarily answer the causal why question for us. So, we also need to go back to perhaps some of the core linguistics work and understand that a bit better to build systems from those fundamentals of why things are working the way they are. All right. So yeah, here's our discussion activity I was talking about before, which is around Google Duplex. So what I want us to do now is to look at and discuss, what do we think Duplex seems to do well? What is it missing as a speech language technology? And what is it missing from a wider societal structural lens? So how many people have we got here? Ben? Just looking. We're a small group, right?
Small group, yeah. Could probably just stay in the.
Why don't we just stay here and discuss? So what I'm going to do though is I'm going to back out. I'm going to turn my microphone off, and I'm just really interested in other people filling the space. So if you don't feel comfortable opening up your microphone, then please throw some things in the chat. But yeah, thinking back to that example of Duplex, what do you think it does well? What does it achieve? But then what is it missing? Taking prompts like I've discussed, or other things that you've noticed from that.
I might follow on from taking on from Hunter's comment from before, the tonality. There's language and dialect would be a big part of that as well. So if there's building a rapport, or that's the social connection, would come a lot from sharing slang words or particular dialect words that maybe a bot doesn't know. Perhaps if a bot could be trained with a certain dialect or with knowledge of certain slang words, then it would likely improve its sense of naturalness.
Lucinda's point, and this is a really good point. For technology like this, I'd prefer that it's open about being a bot, so that you need to guide it. It's a really interesting point, Lucinda, and one that I wrote about when I saw this released, was that the bots didn't disclose that they were bots. So I'm wondering if there's any thoughts around that from an ethical perspective as well, and also from a usability perspective of the disclosure versus non-disclosure of it being a bot. Any thoughts there that people have?
I notice occasionally online, when you get those help chat things on websites, sometimes if they really clearly say that they're a chat or a help bot, then it does moderates the way that you interact with it. So ask particular questions or have certain expectations of the kind of responses that you're likely to get from them. And it also can give you an early out. So I know that if it's a help bot, and if I've got a particular technology need or a particular issue, then it can be an easy way to get out of there quickly, rather than go through that 10 minutes of small talk with the bot before you work out whether you're likely to get a response or not.
Yeah, for sure. Yeah, I noticed, I was concerned that the bot was not, all right, hang on, Savita's got a point. How it would handle unusual missing responses. Like, it feels like it's working with the assumption that nobody's going to violate any of the Gracian maxims. Exactly, right? I think, it is absolutely built around and intends people to behave in a very specific manner with the technology. And when you do get violations, which we do get all the time of those maxims, that yeah, how well is it going to do then? How is it going to pull the conversation back on track? You know, how is it going to deal with those people? And also, I guess this is an important point here from an accessibility perspective. How does it deal with, you know, neurodivergent populations, right, who might not adhere to those maxims in the same way that, you know, others, you know, might be expected to do? So, yeah, there's a key accessibility question for this as well about, you know, have they done testing with those communities with this technology, and, you know, what is the response there from those communities? Is it easy to use? Does it almost disadvantage those communities? Could it be used in a way for accessibility? So in a case of, you know, making appointments and engaging in these conversations, yeah, might it actually be used as an assistive technology? But then at the same time, is it going to start doing that in a way that prevents those people from, you know, engaging in those conversations and some, you know, level of sociality in their day? A lot of questions there, right? And ones that are important to, I guess, you know, in going back to the slide before, working with that end user group to see how they see a technology like this and whether it would work for them. But yeah, it's, you know, in many ways, yeah, Lucinda's point, having worked in jobs answering phones, it could be frustrating, stressful when you hit the limits of the bot's capability. Almost need a code phrase to let the system know it's not working. You need to put the human back in the loop. I mean, on that point as well, Lucinda, that I worked in service for many years while I was in undergrad, and, you know, was on the phone in a retail environment a lot of the time. I hate this technology. You know, one of the points of, you know, working phones is that you actually can connect with other people over the phone. The thought of the kind of larger, you know, Silicon Valley neoliberal capitalistic kind of frame at play here is that a bunch of rich people who can afford this technology are going to now use it so they don't have to dirty themselves talking to low-level service workers. And so it, in many ways, could be seen as extracting the last bit of humanity from an interaction with that restaurant, that hairdresser, or someone else, where they have to actually be, you know, nice and cordial on the phone, and that there is a bit of social connection there. I worry that technologies like this do more to divide society and create some kind of class divide or other power divide between individuals. Yeah, and you're absolutely right. You can waste time and emotional labor with a computer, hard enough, emotional labor, yeah, hard enough in those service industries. Yeah. I think it would be exhausting spending your day conversing with Google Duplex in, you know, making bookings and such. And also, you know, is it the right technology for that? You know, surely there's another kind of calendar technology that could be developed if people just want to book an appointment. We don't need to engage in a conversation necessarily to do that. All right. Keep any other comments coming through because we can go back to it if we need. But I'm going to go back in to share my screen. Oh, sorry, I just need to go back up. So I'm just going to shift now to some of the ways in which we have studied and built technologies to study these kinds of interactions. Oh, so hang on, I just going to make sure I'm sharing this right. Oh, sorry, I'm not sharing that right. Give me one sec. Cool. All right, we're back. So within this, we developed a particular technology here called Pause Code for studying turn taking. And so, you know, one of the really interesting things here in the duplex example and many other examples I've given is understanding in real conversations how turn taking happens. And it's true that there are many communities like discourse analysis and conversation analysis that have looked at this in detail previously. But what occurred to me in working with colleagues in these fields is that they were taking less than perhaps accurate approaches to studying and measuring things like pause length and overlap, given massive advances that have been taking place in signal processing and computer science. Surely there is another way in which we can help them study this particular dynamic. And so that's where we came about designing pause code. So the idea here being, if you take a conversation between two parties, there's a person in red, B, there's a person in A, a person in blue, A. So A in blue is positioned in the top 2/3 of this line. Person B is positioned in the bottom 2/3 of this line. And so what you can see here is that in the start of this conversation, we have, and I'll annotate as I go, you have A talking and B talking and A listening. We have a gap between this point here and this point here where nobody is talking. And what we ascribe this to is that this is a point where A is taking up the turn. So the uptake of the turn at this point here, and then A is talking. Now, sorry, I'm a bit sketchy on the old annotation, but this block here is then A talking. Now, there is a pause where A stops talking about here, and then they continue to talk at this point here. Now, note that B doesn't interrupt at that point. That is A holding the conversation, pausing, and then continuing to talk. So we consider that to be an inner pause. So that's where A has paused and then continued to talk without someone else interrupting that flow. And so that's why it's colored in that particular way. There's points at which you have overlap, right? Where both parties are talking at the same time. And we note that there, and you can see them in those little bits of purple where there's both parties talking. And then there are points at which you get a changing of turn, but at the end and the start of these utterances. So rather than overlap, we see that as an overtake. So someone else has taken over the conversation. Now, there are different terms to describe these behaviors in different literatures. So whether you're in linguistics or you're in conversation analysis or whatever you are, there are lots of different ways in which people describe these, and particular scenarios where they might have different names as well. So the same kind of behavior here is what we call overtake, might be considered as 4 different things depending on what then happens or what might have transpired before. But the point here is not to get into battles around what we call these things. It's that there are ways in which we can codify this activity, and then the ways in which we can start to numerically quantify and understand it as well. So this is what we did with pause code. So you take any kind of conversation between two parties. This is an example of 2 telephone conversations from TalkBank, which is an online corpus of telephone conversation. And what we've done here is put them through pause code to reveal the dynamic of these conversations. Now, when you look at these, at least qualitatively, between the 2 examples, these are 2 very different styles of conversation. On the one on the right, you see massive kinds of turn taking by the person in blue who's talking in these big, long statements. You also see some big ones from the person in red. And you see a bit of a dynamic of them almost holding court back and forth, right? That one almost seems to have, dominance in the conversation, and then it goes back to the other person. You see back channeling and other things. So these very short turns are largely ums and ahs and other kinds of, small verbal utterances back. Whereas, these longer kinds of turns are exactly what they look like. This, for example, here, this long kind of turn by this person in blue that goes for almost 20 seconds. That's, a big turn by them. So yeah, you can start to quantify this discourse and understand its flow. Now, in how we use this, then we can use it to look at things, and we have looked at situations like dementia. So if you have a population, which we know through other testing could be considered as mild, moderate, or severe with regards to the progression of their dementia, we can study the pause behavior. And in fact, we did that and found that, yes, there are strong correlations between specific pausing activities and the kind of particular degree to which the dementia has progressed within those individuals. So yeah, that's one particular way in which we can go about studying these. So a particular theoretical perspective then as well that has guided a lot of this work and the work that precluded this, which is this work in the software technique called discursus, which I'm going to talk about, is a theory called communication accommodation theory. So this particular theory of conversation focuses on how we shape our discourse in response to the interlocutors we're speaking with. So what Kat says is that we have periods of accommodation when we converge in our behaviors. So if someone's speeding up their talk and we speed up with them, that's considered to be accommodation. If someone increases the intensity of their speech and we do that in response, that is also accommodation. If someone changes a topic and we change topic with them, that is also considered perhaps as accommodation. Where we get non-accommodation is when we diverge, where we refuse to change topic, where we slow our speech in response to someone speeding up their speech. And when this happens, we can say certain things around perhaps the relationship between those individuals, their interest in particular topics, and talking about them at particular times. And that's largely what the theory kind of posits, is that some of these things are wrapped up in our own social identities, and how we actually accommodate or don't accommodate other speakers is particularly interesting. It's been used a lot within domains, specialist kind of communication domains like health communication, looking at how different kinds of individuals within a healthcare environment, nurses, midwives, doctors, patients, family members and carers, how they interact or don't interact, and how we might get and expect more convergence or divergence across those particular identity groups. So within this, and sorry, I just realized I've hidden some of my slides. I'm just going to unhide them. Sorry, that's why this thing has been not showing some of them. I will unhide my slides and come back in. Sorry. All right, so we created this technique called discursus. So Janet and I and another colleague, Andrew Smith, way back in the kind of late noughties, developed this particular technique that would take a transcript of a conversation. So this is just a plain text transcript, so a CSV file or something that has the plain kind of what is being spoken. Is a very simple transcript, so we don't need a high detailed transcription with lots of kinds of phonetic level glosses or other things. It's just plainly the words that have been spoken and ascribed to the individuals that mentioned them, just in some kind of an order. So where there are overlaps, we just try and force an ordering there. In this case here, what we're looking at are transcripts from a televised broadcast. So this is from Andrew Denton's Enough Rope program that was broadcast through the noughties. And within this, Andrew Denton, the host, interviewed a lot of different guests. These guests came from various walks of life. So you had experts, so professors and others, and other kinds of scientific experts or subject matter experts. You had celebrities on the program as well. You had lay people who had maybe had some kind of personal experience that was noteworthy that they were talking about. And then you also had accountability. So accountability interviewing is a specific kind of broadcast discourse where you have politicians, criminals or others there, but there is an expectation that the host holds them to account. So is not, doesn't leave kind of controversial statements unchallenged, will hold them to some kind of account or higher standard, because there is an expectation that they might try and use that as a platform to say things that are problematic, untruthful statements that disparage their competitors or their rivals. So there is an expectation that the host, be it a journalist or in this case Andrew Denton, can challenge that discourse to some degree. So in analyzing these using a tool like discursus, so what we see here is what discursus does is it takes a transcript. So if we take the text that we see for this particular excerpt here. So this is just a part of the text here between, in this case, Professor Brian Cox and Andrew Denton. What Discursus does first is it takes the transcript and it builds a conceptual model of this using Leximancer. So Leximancer is a topic modeling system, and it can build a bag of words model from the text that you give it. So it builds some Bayesian statistics around how words co-occur and how we can kind of group those into coherent, what it calls a concept. So a concept is just a bag of words that have a higher than likely statistical likelihood of occurring together within an input text. So once you have the full range of tokens of words kind of mapped down to a much smaller set of concepts, so maybe around 100 concepts for a given transcript, what Discursus does is it goes through and it tags every single turn in that discourse with the concepts that appear in that turn. So in this case here, you've got Professor Brian Cox saying they won't give you the money, you've got to have a reason for doing it. So maybe there's a concept tagged to that that's called money. And maybe there's another concept called reason. And so that's the point, is that you're trying to distill it down from the precise words down to some kind of abstract representation as a concept vector of what concepts appear or don't appear there with a particular weighting. So some concepts might appear more strongly in some turns than others. And so you can create that as a floating point, which means some kind of weighting of that concept within that turn. So what you've now done is you've embedded the text into a multi-dimensional concept vector space. What that means is you can then compare any two of those vectors. So I can directly compare Professor Cox's statement here with Professor Cox's statement here to see, is there conceptual overlap between those two statements and how much there might be. So in doing that, I'm just going to clear this off. If I want to compare, one statement with another, so let's say I want to compare this statement with this statement here, there'll be, I can use a cosine similarity to do that. And how Discursus represents that is that first turn is this one here. And that second turn is, I'm zooming in on this one. Sorry, it's the first turn and the second turn are there, right? So for those, I'll just redraw that so it's all clear. Sorry. So that first turn is that one, and that second turn is that one there. The overlap between them is that point there. So it's where those two squares meet on a horizontal and vertical adjacency line. And there is some overlap. So that is colored. It's a light blue shade, which suggests there is some conceptual overlap between those two statements according to the concept model that Discursus has built. And if we look over the entire discourse here, so this is the first turn in the conversation at the top here, and that was an opening statement by Denton. The last statement at the bottom here by Professor Brian Cox at the end of the conversation, and you see the alternating, question answer pairing all the way through the discourse. So some turn taking. There are moments where we end up with Denton asking two statements with a pause between. So maybe he asked something, there wasn't a response, or there was a significant enough pause in the transcription to write that as two separate utterances. That's fine. But in any case, we see that pattern of turn taking between the two participants largely occur throughout. But importantly, what Discursus shows us is these below the diagonal, where we're ending up with patterns of significant conceptual overlap or a lack of conceptual overlap. So the ones that are highlighted here, you see this high conceptual engagement section here. All these turns seem to have some kind of overlap because you're seeing all that coloring below the triangle there that suggests that, yeah, there is something here. There's a topic that they are discussing at length, and there is a lot of repetition going on there around this set of concepts. So that, and it's between them as well. It's not just Brian Cox repeating himself. It's not just Denton repeating himself. They are repeating each other's statements to some degree. Now, what's interesting is you look at that, and that is classic behavior from an expert guest. When experts go on radio or TV, we are there to talk about our field, right? We're not there to be challenged necessarily. And so often you'll find the hosts work with the expert to continue to help them elaborate and couch things in terms that a lay audience can understand, right? So kind of de-wonkify our expert talk. In this case here, that's what we kind of see going on. On the right-hand side, we see Renee Rivkin, who was convicted for insider trading, did time for that crime, and upon their release, went on Andrew Denton's program to do an interview to perhaps restore some kind of trust or kind of rebuild their brand. Now, what we see here is a very different form of interaction. We see repeated questioning and we see evasive answering by Rivkin. So, within this host repetition checkerboard, as we call it, you note that all the repetitions happening by Denton repeating his own question. So this is a standard accountability interviewing tactic of repeating the question. It doesn't happen nearly enough, if you ask me, on Australian news TV. Journalists let answers go unchallenged too often and don't ask follow-up questions. Andrew Denton, in my professional opinion, is a much better interviewer and particularly good at accountability. Ask the follow-ups and make sure they get to some kind of notional truth. So here we see this repetition checkerboard where they're asking the same question: what happened? What happened? No, come on, tell me, right? That there's that repetition in a line of questioning going on, and that's why we see that checkerboard there. So I'm just going to put away my annotation tools. So what else can we do with this? So what we can do, as I said, once we start doing this, you can qualitatively interpret what's going on, but you can also numerically quantify this activity. So we can look at, for example, how things repeat or recur, because this method is an extension of recurrence analysis. So, these are recurrence plots, and we extended in some work that Janet and Andrew and I led this idea into quantification as well. So how do we measure these things? So we came up with what we call the set of recurrence primitives, which is looking at repetition forward in time. So if I say something, how is it repeated by me or others from that statement moving forward in time? You could also look backward in time. So how much am I repeating stuff that's happened previously in the conversation? So how much am I calling back to previously discussed ideas by myself or others? So that's the type, right? So am I repeating myself, or am I repeating other people in the conversation? Direction, backward and forward. And of course, time scale. Are we talking about the immediately previous utterance, 10 utterances prior to that, or the entire conversation? So when you combine those, we end up with 12 different combinations of the time periods: short, medium, and long, direction forward or backward, or type self-repetition or other repetition. And when you do this, it turns out you can know some things around particular discourses. This is an example of when we applied the technique to dementia conversations with people living with dementia and their care providers. And we found that some of these were able to predict particular kinds of interaction styles. So there was a kind of a conversational approach that was designed in many ways by a team led by Helen Chenery, a very good colleague of ours. And this particular strategy, it was called Message, promoted particular kinds of active listening, particular acknowledgements, self-disclosures, other things that were seen to perhaps be able to help generate productive discourse with people living with dementia. And when we coded conversations for when these strategies were being deployed, we found that Discursus was able to locate with some strong statistical significance that these led to particular forms of recurrent behaviors. So there was a correlation between what we could quantify with the technique and the strategies as they were being deployed. So in a way, we developed a technique that could detect automatically when these particular strategies were being deployed. We've also used this to look at big, massively multi-party conversation. So if you can know how much individuals repeat each other, you can do that not just with 2 individuals, you can do it with lots of individuals. And so what we see here is a network diagram showing the degree of conceptual overlap in SBS Insight, which is a big panel discussion program. What's interesting here from a communication theoretical perspective is how this helps us understand notions of what we call privileging the expert, right? Or like expert repertoire. So the idea of expert repertoires is like academics, we always do it, professionals always do it, that we tend to use jargon and ideas that situate within our field. We talk to each other, right? And on these discussion shows, this absolutely happens, where experts end up kind of talking in shop language with each other. And what that does is it perhaps excludes the lay people on these panel shows. So they're not necessarily repeated, or their kind of anecdotes are just sitting there as that. They're just anecdotes. They don't gel with the language of the expert clique. There are exceptions to this. As we see here, there's one particular individual in the middle of this discourse, Susan Candlish, who is on the program. Now, the difference there and where we get exceptions is Susan Candlish was the first one to really tell a story around a particular experience of a hospital emergency room. That was the kind of catalyst for a lot of discussion. So they're repeating her story in many ways in framing their discussion. But for anyone else on that program, be it Carol Hamilton on the right-hand side, Michael Osborne, Margaret Donkin, Brian Beggs, any of these other lay people that were there to talk about their story, those stories were not really integrated into this discussion beyond their own anecdotes. Instead, those professionals tended to preferentially engage with each other's discourse. All right, so that's discursus at the end, and some technologies. That pretty much takes us to time. I had one little show and tell as well, though, which and while you're kind of thinking about questions, this is a little chatbot that I grabbed the other day. I run a little chat tech unit here in our master's program, Masters of Com, and I do a whole section on embodiment. And in fact, I recorded a lecture with Janet on this, and grabbed this little guy here for a bit of show and tell. But just an interesting example of kind of consumer tech and where it's going. So this is marketed to children, right? This is a build at home chat technology. It has a button, has this little beautiful LED array at the front, and it integrates with a cloud service. So you can ask it a question. I'm just going to ask it to tell us a joke. So I'm just going to hit the button. Oh, it needs Wi-Fi. Hang on. I'm going to turn my what? Oh, yeah. Let me see. Tech fail. I usually hotspot this one off my phone, but I'll see. Spencer. So what it does, it just connects to a Wi-Fi hotspot you set up. So I've got one set up here. Yep, so it's connected. Let's see if it can tell us a joke. Spencer, please tell us a joke. So what it's doing is it sent that up to a cloud service, converted the speech to some form of text, is formulating a response, and is going to get back to us in some time.
When do robots overheat? When they need to vent.
When do robots overheat? When they need to vent. So yeah, terrible joke, Spencer. But yeah, that lag is awful. It's a good toy. It's not really useful technology, but yeah, I thought I'd bring it in just to show you.
Is that something that one of the master students has built?
No, this is it's a consumer tech. Yeah, you can get it. This is Circuit Mess. But yeah, interestingly, how these technologies, it is marketed towards children, kind of doing this kind of thing. Oh, so funny! Look, it's picking out the head in that. But yeah, it's basically learning how to build technologies. It's all Arduino based, but just kind of, I guess, where we started this talk, the 50s and such, and questions around like ELIZA and that, and this is kind of where we're at with this kind of throwaway technology now that can do some pretty incredible stuff. But I guess also the frustration that it completely relies on a cloud service to do anything. And of course, because of that, there is a massive lag. So it's not really useful and usable as a chat technology.
Has anybody hacked them to load local data sets?
Yep. So you can, it gives you a Scratch-like interface that you can use to reprogram. So imagine you could do some pretty cool stuff with it. It's got a microphone, it's got a microprocessor on board. Most of the computation happens off in the cloud, but yeah, it's an interesting tech just the same.
I saw Google had some products that were based on their cloud speech and cloud image services a couple of years back, but they were typical Google cardboard box thing.
Yep.
But same, they were interfaces to the cloud services with the bit of Arduino, Raspberry Pi sort of stuff happening inside them.
Yeah, so this has got, it's an ESP32 inside there. That's just one board, and that's mostly empty space inside that box. So there's not a lot inside there. One speaker, this microphone, and this LED array, which just is largely programmed, with very simple patterns. So yeah, there's a lot of circuit board and not a lot of circuits. It's basically one ESP32 chip, and that's about it.